Okay, class. So let's go to the paper. Okay. Which paper I asked you to do? Paper 1, July 13. I think paper 1, July 13, right? This is the paper.
Yes.
Okay. So let me go through the paper 1 first now. Okay. So as usual, troubleshoot whatever question you got a problem. Any questions you have a problem in this paper? Have to check the mark scheme. Anyone? So you tried this paper? Any questions from this paper you have a problem? Oh, we done this paper. I think I select some questions, is it? Oh yeah. Any questions from this paper?
Teacher, number 7. I don't understand.
Number 7, okay. So we go through number 7. Okay, those who haven't tried, give a try. Number 7. Okay, it's so projectile leaves the ground at an angle of 60 degrees to the horizontal. Its initial velocity is v. Neglecting air resistance, find the term of v velocity at the highest point of the motion. Find in terms of v its velocity at the highest point. Okay. Yeah. Last time when we do projectile, I told you that at any moment you have two velocities. Okay, you have the horizontal velocity ux, and the vertical one is the uy. When the object's launched, at any moment, the v will be like the vx and the vy. You get the vx and vy, you can find the v. You know that the v is equals to what? That vector diagram. Vx, Vy. So V squared equals to Vx squared plus Vy squared. At the top, at the peak point, it's a little unique because the V should be a straight line. The V should be horizontal. The V, which component becomes 0? The Vx or Vy? Because it's moved perfectly horizontal, If it's moving perfectly horizontal, the Vy become 0, no Vy component. But it still has Vx. It still has Vx. Vx is still there. So conclusion is V squared of Vy squared plus Vx squared. So because Vy is 0 at the top, only happens at the top. So V is same as Vx. Vx is same as Ux, right? The initial velocity Ux. Ux never changed, right? The horizontal component never changed. So V cos. So what is your Ux value? You resolve the V down, so it's V cos 60. Yes. So your Ux is V cos 60. So therefore your V is V cos 60. V cos 60. So cos 60 how much? Cos 60 half, right? Half. So therefore answer is V over 2. So B. So at the top, you need to remember that Vy becomes 0. So V is Vy squared, Vx squared. So Vy becomes 0. So V become Vx on the top. The V is same as the horizontal component. But horizontal component of the velocity is always same as the initial horizontal component of the velocity, Ux. Ux same as Vx. So cos 60 is half, so V over 2. Can you understand? Can, Okay. So, any other questions?
Question 13.
13. Okay, 1, 3. Let's go to question 13. Okay, question 13. Okay, the others I haven't tried. I have an idea. Which of the following statement relating Newton's third law? So Newton's third law, action reaction. Two forces must be the same type. Yes, correct. I told you that action reaction, the type of force must be the same type. If let's say you and the earth pulls you action, the earth pulls you action, you pull the earth is reaction. Both force is the same type of force, both gravity. Action reaction must be always the same type. The two force must act on a different body. Yes, the body 1 and body 2. If action is to the 2 means the reaction should be to the 1. The two forces are equal and opposite, so the bodies are in equilibrium. That's wrong. The force, of course, equal, oppositely directed, but doesn't mean the bodies are in equilibrium. The body not necessarily in equilibrium. The two forces are always opposite direction. That's correct. Because see, let's say you take this body, you are moving downwards to the earth. Okay, are you in equilibrium? And the earth pulls you down. Are you in equilibrium? You have a net force. What? Your net force is your weight. So you are not in equilibrium. So the two forces are equal and opposite chord, but not necessarily the body must be in equilibrium. Okay, the body 1 exert a force in 2, the body 2 exert in force on 1. Makes both of them will experience kind of maybe a deceleration. Deceleration will happen due to impact. Due to impact, there might be a deceleration. So anything as deceleration, they are not in equilibrium. They have a net force. So C should be the answer. It's not correct about Newton's third law. Okay. So the answer is C, is it? C,
Yeah.
So you understand?
Yes.
Okay, good. Any other question?
Question 17.
Okay, let's go to 17. Following statement about the experiment is correct. Okay. Okay. So I think 2017. I think they did some changes to the syllabus. This is a 2013 paper. This is not in your syllabus. Brownian motion was already pushed to A2. Okay, so we will be doing that in A2. So no need to. Any Brownian motion, any particle movement, not in A2. It's all in A2. Sorry, not in ES. So I think not necessarily discuss this 17. It's in A2 later. Any other question?
18.
18. Okay, good. Okay, 18. So the densities of water and steam are these two values. What is the ratio of average separation of steam molecules over the average separation of the water molecules? Okay, how do we find this? Okay. Okay, the question asking for, let's say you have a steam molecule. Okay, this is steam molecule. Steam molecule separation, X of steam. And the other one is X of water, and the separation of water. They're asking what is X of steam over X of water, how much? Okay. Okay. How this separation linked to density? Because they give density. They're asking for separation. How separation linked to density? Okay, that's what, if you know the link, you can get the answer here already. What is density? Density is mass over volume. Okay, so if you take mass of one molecule, if you take mass of one molecule, the volume should be volume occupied by one molecule. Volume occupied by one molecule. Okay, so that spacing related to the volume of the molecule. Spacing is what? Related to the volume of the molecule. You see, here you have one molecule. The molecule has a spacing of x, so it will have a spacing up here x, and into the page x, like 3 dimension 3x. So that means one molecule, the spacing it occupies, the volume it occupies, we assume it's like in a cube shape. In a cube shape, there's another particle at the side. Okay, we say it's in a cube shape where the length of the cube is x. The length of the cube is the x. X is the separation of the molecule. Okay, you see, from here to here is the separation of molecule x, but you have another molecule. Okay, the center to center also x. You see, you have three molecules. From here to here also x. From the center to center also we consider as x. Okay, what is x? The average separation. So the volume occupied by one molecule is in terms of cube. So how do you write volume in terms of x? How do you write volume in terms of x? Yeah. The density equals to mass of one molecule divided by x cube. That's the link. X cube. X is the separation of the molecule. So what is separation? Will we make the separation as a subject? It will be mass over density cube root. Be cube root. That's your separation. Okay. So from here, we want to find what? Separation of steam over separation of the water is actually cube root of mass of one molecule divided by density of steam. Density of steam, cube root, divided by what? Mass of the one molecule divided by the density of the water, cube root. Okay, so after this is mass of both molecules is the same because both are H2O, so molecule same, so the mass of the molecule same, so we can cancel. We can merge them, right? We can merge them. It's going to be what? It's going to be cube root of what? Density of water over the density of the steam. That's going to be the ratio of the spacing steam to the spacing of water. So this is the final conclusion. Okay, this is the final conclusion. So now can you get the answer? The average spacing of the steam of the average spacing of molecule is actually cube root of density of water or density of steam. So I do here, what is the density of water? Cube root, density of water is how much? 1000, 1 times 10 power of 3. Our density of the steam is 6.1 times 10 power of -1. Cube root, what do you get? Anyone? What did the answer get?
11.7.
Okay, so it's 11.7. Good, thanks. Therefore, should be A. A is the answer. Okay. Any part you don't understand here? So, can
Yes.
the volume is the volume occupied by one molecule is actually the spacing cube. That's the important point you need to link. Okay. So the volume, we take it as x cube. X is the spacing of the molecule, one molecule. Because 3D will be x, so it become x cube. Volume occupied by one molecule is x cube. X is the spacing. Okay. Then you do rearrangement. You can find the spacing of the both body is cube root of density of water over density of steam. Okay. So Any part you don't understand here? Can understand, eh? Okay, we go to the next question. Any other question? So no questions. So no questions, then we go to the any other papers if you have questions. If you don't have questions, then I go to a new paper, then I ask random questions. Any other questions? Okay. So if you don't have questions, then let's we go to the next paper. Eh? Okay, final call. Any questions? No questions, eh? Okay, so let's we go to the different paper. Eh? Okay, so paper 1 July I asked you, 13 I asked you to do, we discussed just now. Another paper I asked to do, I think paper 2 March 14. Paper 2, you have any problem? Okay, normally even seniors, paper 2, the mark scheme should be quite well explained to you. Eh? Okay, so let's redo paper 1 again, July 12th. You don't have anything, I go to paper 12. Paper July 12th. Paper 1 July 12th. Eh? Okay. Oh, this is giving answers. Is it answer? Paper 1 July. Oh, I think I wrongly labeled it. Okay, class. So this is July 12th. Eh? Okay. Let me select random question, which might makes me. Okay. We done this paper. No. Eh? Okay. This question. Question 9. Give a try. What's the answer? Okay, you can send through WhatsApp your answer. Question 9. Okay, so yet I receive answer. So an elastic cord, it's an elastic cord pulling both. Okay, pulling both of them to the center. Okay, one of your friends saying is A. Is it A? More answers, please. Because it pulled by the same force. Because elastic cord, what? Same elastic cord pulled them with the same force. Because it pulled by the same force, therefore, force is what? Rate of changes of momentum. Okay, this is for the X, and this force is, of course, rate of changes of momentum for the Y. Okay, good. Another one of you said A, 2 of you said A, same answer. Okay, so the force pull is the same. So the rate of changes of momentum of X and Y must be same. Newton's second law. Do the time of movement when they meet up, the time of movement is the same. The time of movement is the same because pulled by the same cord. When they hit, the time of movement should be the same. So the changes of momentum experienced by the both body must be the same. Must be the same. When this come to, or another word, you check the momentum. What is the total momentum of the X and Y? The total momentum before collision should be equals to total momentum after collision. So before collision, momentum of X should be minus momentum of Y because Y is moving to the left, X is moving to the right. Okay, after that, momentum of X plus momentum of Y. Before collision, momentum of X is how much? When come and meet up, when come and meet up, the momentum of X and momentum of Y going to be the same. X and Y going to be the same. Why is going to be the same? Because both accelerated by the same force, time same, time of traveling same. Both start with initial velocity 0, so mu don't have. So both will have the same momentum when they collide. So Px and Py is same magnitude. So total momentum before collision is 0. Okay. After collision, X becomes 0. So therefore, Y also must stop moving, must be 0. So therefore, the answer should be A. A. So based on what? Conservation of momentum. Total momentum before must be same as total momentum after. Px plus Py, but Py considered as negative because moving to the left. The Px and Py, when they collide, must have same momentum because this is the force pulling them. By the time of applying that force for both of them same, the initial momentum is 0. So the final momentum just before colliding will be mv, same. So Px and Py is same. So 0 total momentum before collision same, 0. After collision, Px is found to be at rest. So Py also must be 0 then. Okay, so any part you don't understand here, so answer those who got A is good. The answer should be A. Okay. Okay. More questions? Okay, question 10. Give me the answer. Okay, so yeah, I'm receiving answers. So again, 2 of you said is A. One of you said A, sorry. Okay, one of you said A. Okay, another one said is B. Okay, now is it B or A? Think carefully. B or A? The two force, if it's an action reaction pair, they have must have some feature. They must be same type. What else? They must be oppositely directed, same magnitude, and must act on different body. Students normally messed up with the last point. It must act on a different body. Then they messed up with the first point. Must be same type. Opposite, same magnitude, normally is fine. Okay. W and X or W over Y. W and X is an action reaction pair, or W and Y is an action reaction pair. Okay. Weight and the contact force, is it an action reaction pair? As I said last time, if you stand here, okay, weight acting on you down, and normal reaction also acting on you on the floor. The normal reaction acting on who? Normal reaction pushed by the floor to you, also acting on you. So weight and the normal reaction is acting on the same body. U. So because the normal direction and weight acting on the same body, the fourth point, action direction pair must act on a different body. So in that basis, weight and normal direction cannot be action direction pair. W and Y is the contact force. The contact force is the normal direction. Is the normal direction. So of course W and Y cannot be action direction pair. Why reason is it act on the same body. It should act on a different body. All the other features look same. Magnitude, they have same magnitude. They are oppositely directed. They are not same type. One is gravitational force. Another one is pushing contact force. The main point you can check is different body. So B cannot be the answer. A, yes, A is the answer. Okay, weight is another name of force, gravitational force by Earth on the person. If there is a person here, the weight is actually the gravitational force by who? By Earth to the person. You see the X is the pull of person on the Earth. Yeah. So the second X is the pull of person on the Earth. The Earth pulls the person pulls the Earth up. That's reaction. So WX would be the action reaction pair. Act on a different body, same type, both are gravity, oppositely directed, same magnitude. So answer is A. Okay, remember it's a very wrong idea. Many, I think not one, close to 95% of the student after O level when get to A levels, when I ask, is it weight and reaction force is an action reaction pair? I think 95% of the student will say yes, but actually not. Why not? The both body acting on the both force acting on the same body. If it's an action reaction pair, the force must act on a different body. Okay, so weight and reaction is not a normal reaction. It's not a action reaction pair. Put in your mind. Okay, any problem with the question 10 explanation? Can Okay, so I select more questions. Okay, this one. Question 14. Okay, 1 minute for you. Give a try. This is an interesting one. As usual, text me answer. This is moment. Your fourth topic, fifth topic, moment. Talk of force times perpendicular distance, right? A uniform locked door of weight W and length 0.8 meter is in equilibrium. It is hinged at X and supported by a rope passing over a pulley. Okay, the tension in the supporting rope is T. Tension in the supporting rope is T. Okay. Which of the following equation applies when moments are taken about X? Is it in equilibrium? Is it the, oh yeah, it's in equilibrium. Okay, so the clue is the door is in equilibrium. Okay, so the door is in equilibrium. So this is in equilibrium. This is in equilibrium. Okay, identify all the forces, then you can get the answer. Check what are the forces acting on this rod. Then you can get the answer. The tension acting up. What are the force acting on this what do you call, on this door? The weight acting at the center straight down. At the hinge here, at the hinge here, there will be a force. There definitely is a force at the pivot. So there is a force here. There is an unknown force here. There is unknown force acting here, which we don't know. But the question is don't want nothing to do with this force. They don't want this force to appear in the equation. So best is take moment about the pivot take moment about the taking. Okay, take moment about the pivot. Moment about the pivot. Okay, taking moment about the pivot. Then this force won't appear. So write the equation. Clockwise moment must be equals to anti-clockwise moment. Then you will get the answer. Anyone? Please text me your answer. Okay, the others, please give a try. Yeah, one more of you try and give me the answer. Okay, so take moment about the pivot, then you form a force, form an equation. So the rod is like this. Okay, the rod is like this. Weight acting down, mg, and the tension is up here. T is up here and pivoted here. Can you write, because the system is in equilibrium, what is the condition to be in equilibrium? The net force must be 0. Another one rule is what? The moment, the resultant moment about any point on the object must be 0. So you use the moment, you can get the answer for this. Leaking T and mg. Okay, tell me mg gives what type of moment? So one of you said answer is B. The others come and give a try. Okay, another one of you said is A. Okay, now we got 2 answers. Come on, please check back. Is it A or B? Oh, another one of you saying C. So, or yeah, 2 of you, the one said A, 2 of you said B, and 2 of you said C. B or C? Check this diagram carefully. B or C? 50-50 your class results. So the moment caused by mg is what moment? It's a clockwise moment. So what is the moment caused by mg? Mg times the perpendicular distance, right? This is a perpendicular distance. How much is the perpendicular distance? 0.8, half of 0.8 what? 0.4 cos 40. This perpendicular distance is 0.4. Oh, I can put in terms of, yeah. It's 0.4 cos 40. That's your this horizontal distance, right? This is 0.4 what? Up to here is 0.4. You resolve down, you got 0.4 cos 40. So the clockwise moment is mg times, we can put, because they put w, so we put w like w times 0.4 cos 40. Okay, that's a clockwise moment. Clockwise moment, mg is a clockwise moment, equals to moment caused by t. T times, what is the perpendicular distance? What is the perpendicular distance? This is the perpendicular distance for the t. How much is the perpendicular distance? Is 0.8 cos 40. Yeah, 0.8 cos 40. So this should be tension times 0.8 cos 40. So therefore, cos 40, you can see it cancels. So it's actually W times 0.4 is equals to 2t times 0.8 lah. So the answer is C. Answer should be C. Okay, good. Those who are giving C is correct answer. C is the answer. So this is the working. Take moment about the pivot because we want to kill the unknown force at pivot. Pivot always will be a there will be a force is unknown. To get rid of that force, you take moment about the pivot. So we don't need to think about that force lah. So clockwise moment is equal to anti-clockwise moment. Moment caused by W is W times 0.4 cos 40. And moment caused by the tension is tension times 0.8 cos 40. Cos 40 cancel, so you get C. Okay. Any part you don't understand? Anyone? Okay, okay, good. Okay, let's continue more questions. Okay, not this one. Glass fiber, young, more than this. Oh, it's all okay, like manageable. Okay, question 31. Give me the answer. 1 minute for you. Electric field. An electron is in electric field strength that much. The field is the only influence on the electron. That means they ask you to neglect the weight lah. The mass and charge of electron are known. Okay, normally the charge and mass of electron will be given in the front page. Mass of mass of electron and charge of electron, they put it as elementary charge. Which quantity can be calculated without any more information? Okay, so I got answer A. So two of you said A. Which quantity can be calculated without any more information? Okay, all of you said A. So I think shouldn't be a problem lah. Okay, all saying A. Okay, so force is the one can be calculated. So force is what? F equals to QE. So E, Q we know, so force can be calculated, of course. Momentum is mass times velocity. Mass we know, mass of the electron we know. Speed we don't know lah. Speed we don't know. Directly we cannot calculate lah. Which quantity can calculate without any more information? Yeah. Kinetic energy also need B, so cannot. Speed of electron, yes, cannot. So of course A is the answer, easy. Okay, good. The answer is A. Okay. Okay, good question. 32. Give me the answer. It's tricky. 32. Send me answer. So electric field again. Two horizontal metal plates are separated by 4 mm. The lower plate is -6 volt. What potential should be applied to the upper plate to create an electric field of strength of 4 1000 volt upwards. Okay, I receive answer B, boy. Is it positive 10 volt? Please read the question carefully. There is some hidden information there which can make you answer wrong. Is it B? The keyword I think you can misinterpret is this upwards. Okay, so yeah. So now your friend changing the answer to D. It's D. Or two of you saying D. So nobody is saying B anymore. All of you saying D. Two of you saying D. Is it D? So they want the electric field strength to be upwards. So electric field strength is, in this case, we use V over D. So E is 4000. V we're looking for. D is how much? Is 4 mm. So 4 times 10 to the power of -3, change to meter. So therefore, we get how much? We got 16 volt. That means the potential difference between them must be 16 volt. But because the field they want it to be upwards, that means lower plate is positively charged. So the field line should be up. The field line, because they want it to be upwards, the field is upwards. So conclusion is the upper plate must be even lower potential than down plate. Down plate is already -6 and the potential difference is 16 volt. So upper plate must be lower than -6. So should be how much? -22 volt. -22 volt. 6 plus 16, just the magnitude. So you should be in 22, -22. -22 even lower than the field will be upwards. So therefore the answer should be D. Good. So check, is it upwards or downwards? If it upwards, down plate will be negative. In this case, they trick you because down plate itself is -6 volt. That means upper plate must be even more negative by 16 volt drop. So it should be -22 -22. So in this case, down plate is positive, upper plate is negative. Relative what do you call sign? Okay, good. So those who got 22, -22. Any questions from here? Okay, can okay, after that we can't go through any of the questions because we haven't learned that. Okay. 26. 26, your wave. Calculate, give me the answer. Hope I can get the same answer now. What's up, me? In a young double slit experiment, small detector measures the intensity of illumination of E at center of the fringe pattern. What is E? Okay, let's see. If one of the two identical slits is now covered, the measure the intensity is E at the center. Okay. When one of the slit is now covered, how much is the new intensity now at the center? So this is your intensity knowledge. Oh, sorry, what happened? Let's go down. Okay, go back to the question. Yeah, question 26. So please, anyone, give me the answer. So far, I never received any answer yet. Intensity proportional to amplitude squared. I think this is the one you have to use here. You have double slit. At the center, you get a bright spot, of course. So the two waves are traveling, okay, and produces the intensity here. They said is E, okay. Now they block the first one, so this wave won't reach there. Only one wave is going to reach there. What is the new intensity? How many E? That's the question. Okay, I receive answers. Oh, different answers. Okay, two of you said D, one of you said C. 2D, 1C. So D or C? D or C? So two of majority says D. Majority says EO4. Two of you said EO4, one of you said EO2. EO4, EO2. Use this concept, intensity proportional to amplitude squared. When two waves meet at the center, how much is the amplitude going to be? If this amplitude is A and the other amplitude is A, the center when they make intensity E, so that means E proportional to how many A? 2A squared. 2A squared, right? This is the first equation. And they both wave with the amplitude of A. We assume amplitude is A. A become 2A when they meet up. So the intensity at the center is proportional to 2A squared. First equation. When first one is blocked, only one wave goes there. So the new intensity X is proportional to, what is the new amplitude going to reach there? Only one A one. The other A was blocked. So the new intensity is just proportional to A squared second. So find the X. Find the X. I think you still remember what I proportional to A squared is same as I1 over A1 squared equals to I2 over A2 squared one, as I told you last time. So here we put these two data. So E over 4A squared. 4A squared. 2A squared is 4A squared. Is equals to X over A squared. So what is X you get? Is E over 4. So it's E over 4. So therefore answer is D. Okay, good. Those of you got D. Yeah.
Why should I square the 2 in the A square?
Because the formula is intensity is directly proportional to the amplitude square. The 2A is the amplitude, not A amplitude. 2A is amplitude. So the 2A have to be square. The 2 also have to be square. Okay, because it's amplitude square. The entire A must be amplitude square. Okay, so if you have a wave with A, so I proportional to A squared. If you get amplitude of 2A, then the intensity is proportional to 2A bracket squared. So the 2 also need to be squared. So it's me up 4A squared. It's because the amplitude is 2A. 2A, the amplitude need to be squared. Okay. So if an intensity, if it's 3A, then we say I proportional to 3A squared. The 3 also squared. So it's become 9A squared. Okay, you can't miss out the 2. You have to include the 2 because 2A is the amplitude. The intensity is directly proportional to the amplitude square. Amplitude square, whatever amplitude, we square it. This wave is 2A is the amplitude, the 2A amplitude is squared. Okay? Can you understand?
Yes.
Yes. Okay, good. Okay, class. So, any other questions you have? Yeah. Okay, let me go through the last one. Okay. Question 21. You were trying? Well done, sir. Okay, send me the WhatsApp. The half FL is only can be considered correct if what statement is considered. The extension of the wire is proportional to the force. The weight of the wire is neglected. The wire is not stretched beyond its elastic limit. Or the cross-sectional area of the wire remains constant. Okay, so I receive answer A. Yeah, should be A lah. Should be A. This half FL means if you plot force versus extension, it must be a straight line. Then only you can use, let's say the extension is L. So that's the energy going to be half FL. So half FL is the energy stored as long as it's a straight line. Straight line means the force must be directly proportional to the extension. That's the only condition to use energy stored as half FL. So A is the answer. Weight of the wire is neglected, not an array. Wire is not stretched beyond elastic limit. The wire is not stretched beyond limit of proportionality. Then could be the answer. Not elastic limit. Elastic limit, the graph is already curved little. Okay, I told you the limit of proportionality is the tip of the straight line, where the Hooke's law is considered. After that, limit of proportionality. So limit of proportionality, the graph is already curved. So half FL not applied anymore. So A is the answer. Okay. Okay, class. So do more questions. Do more questions. So we done some here. You try to do as more question as possible. Then if you're done with the semester papers, you can give a try with the AS trial. AS trial papers are more challenging, but if you can able to explore more, as more questions you explore, more prepared you are for semester exams. So remember the what you're going to face a problem is, I don't think so idea maybe you might have the good idea for all the questions, but the problem is the time factor. Try to finish every objective like 1 hour, one quarter minutes, okay, for every marks. Remember that. Okay, towards the end here, sorry, not the trial. So here I give you I posted the AS definition list here. So you can download this. So you have all the definitions here. Definitions with all the equations at the side. So you need to memorize the definition. Okay. So you need to memorize up to topic what? Up to topic superposition, up to electric field. So there are 52 definitions for you to remember. Okay. Definition carries about maybe around 10 marks of the paper 2. It's your definition marks. Okay, any question, guys, so far? Okay. So, okay, good. Thanks. So I see you back next semester, maybe in 2 weeks' time. 6th July, I think we start class again. Okay. So by then, I hope you can do best. I see you back. If you still have any problem, you can WhatsApp me. We can interact with WhatsApp. Okay, if you have any problem with the coming questions. Okay, class, good luck for your exam. Okay, any questions? No questions. Okay, class, see you back on 6th July. Good luck for your exam. Okay, bye.